So student, we will discuss now the question number 1.30 additional exercise, electrical charges and field. In question number 1.30 they are saying obtain the formula of electrical field due to long thin wire of uniform linear charge density, which is E, without using Gauss law. Hint, use Coulomb's law directly and evaluate the necessary integral. Obtain the formula of electrical field due to long thin wire of uniform linear charge density, they are saying. Now see, without using Gauss law, we need to find out this long thin wire electrical field in a certain point of a distance from this wire might be L, and electrical field we need to find out this one point A here. Now you see, suppose the linear charge density initially we say this is sigma, and we consider one particular section of this wire which is dx length, and it is from the distance of maybe midpoint you can say of this wire, and you consider wire perpendicular to this x distance from this point, and it is making an angle theta to the normal. So the charge at section dx here, this will be q dx, this will be q equal to lambda into dx, and electrical field due to this E, this direction, because this will be positive test charge electrical field. If we say this is positive 1, suppose consider this is wire is positively charged, so electrical field will be this direction, and electrical field due to this dx will be small, suppose this is, we can say delta E, very small one, and this mod will be value will be lambda dx, this is q, by 4 pi epsilon naught into this, as this is x distance, and this will be obviously root of L square plus Pythagoras theorem, hypotenuse will be L square plus x square. So the distance from this dx is root of L square plus x square whole square. So field due to dx will be lambda dx over 4 pi epsilon naught whole into L square plus x square. Small electrical field due to dx. Now from this triangle you see x by L, you can say x by L is, this is tan theta, x by L is the tan theta is the theta, or x equal to L tan theta. If you differentiate this one, you will find this is dx equal to L sec square theta d theta. From trigonometry, I think you know this one. So we will put this one lambda dx over 4 pi epsilon naught, and L square plus x is L square tan square theta, and dx could be replaced as lambda, and dx we found L sec square theta d theta over 4 pi epsilon naught, L square common you can take, and this is 1 plus tan square theta. Also here you see this is the total value of this magnetic field, and 1 plus tan square theta, you know lambda L, so 1 L will be cut here, so only up will be lambda, and d theta over sec square theta, and 1 plus tan square theta also sec square theta you know, or you can write initially sec square theta, then 4 pi epsilon naught and L into sec square theta, so both will be cut, only lambda d theta over 4 pi epsilon naught L. This is the field effect due to dx, small portion of dx of this wire. Now one thing you see here, all the field here, if you consider a point, this will be direction of this point like this, and if we resolute these vectors into two component, two component. One will be vertical component and another will be horizontal component. And for all particular this portion charges electrical field, this all parallel line will cross each other. This all parallel line, half of the part will put this amount of force this side and half of the part of this small dx part will affect this, keep on adding this side all forces, and this force will neutralize this force, will neutralize this force, because this is opposite and equal. Only remaining this theta, this part theta, this is the cos theta part, means E cos theta part will remaining, and it will give us the electrical field. So for this component, for D also, here also, dE cos theta will be the effective electrical field of this. So we'll say this will be lambda cos theta d theta and 4 pi epsilon naught L. Now see, this is for a small segment of dx. Now if you want to find out due to the whole wire, infinitely long wire, for this point creating this electrical field, we have to integrate infinitely long, integrate this dE and cos theta, which is nothing but the integration of lambda cos theta d theta over 4 pi epsilon naught L. And as this is infinitely long, it is not so long, but in terms of this L length, it is infinitely very high, very excessive, very vast length. In terms of this is small L, this is small L, ratio between L and this length of this wire is very high. That's why we said this is infinitely long. So in case of infinitely long, what is happening, this theta will be gradually actually going to this one 90 degree. This will gradually, it will going to increase and it will stop somewhere at 90 degree. So this theta will be minus pi by 2, this side minus pi by 2 and this side plus pi by 2. This will be working in the range of theta total minus pi by 2 from minus pi by 2. So these are the constant lambda, let it come out from the integration 4 pi epsilon naught L, and the remaining is cos theta d theta, then minus pi by 2 and pi by 2. So this is lambda 4 pi epsilon naught L, and this is cos theta, integration of cos theta, you know it, though this is sin theta, and this value range will be minus pi by 2 up to plus pi by 2. So what is here actually? Lambda over 4 pi epsilon naught L into sin 90 minus sin minus 90, which is coming pi 4 pi epsilon lambda by 4 pi epsilon naught L, and this is sin 91 minus 1, so this will be plus 1 actually. So this is coming lambda by 4 pi epsilon naught L into 2. The total electrical field, this is what? This is actually electrical field, overall electrical field, this one. So electrical field will say lambda by 2 pi epsilon naught L. This is the electrical field, net electrical field due to infinitely long charged wire. If you put the direction, it will be the perpendicular direction to this long wires. If you put n cap, if you put the vector form, so this will be lambda by 2 pi epsilon naught L into n cap, which is n cap is any point perpendicular to this, normal to this wire, this will be the direction. So without Gauss law, by integration we can also prove that electrical field due to infinitely long wire will be linear charge over 2 pi epsilon naught and the distance of the L where we want to find the electrical field. Okay, thank you.